In the first segment, we looked at the definition of logarithmic functions and then also looked at rewriting logarithmic functions to their exponential form, rewriting the exponential form of logarithmic functions to the logarithmic form, and then evaluating some logarithmic expressions. In this segment, I'd like to work a little bit more on evaluating logarithmic expressions where the argument, or what we're taking the log of, is a power of the base. That is one that's easy to work out without a calculator. So with these examples, let's just go through one by one and talk through the process. In my first one, I have log base 3 of 81. Now remember, logarithms are the exponent that you put on the base to create that value. So what you're thinking is here, 3 to the what power would create 81? And we want to figure that out. Well, 3 to the first is 3, 3 squared is 9, 3 cubed is 27, and 3 to the fourth is 81. So the exponent I put on 3 to create 81 is 4, because 3 to the fourth is 81. Let's do the next one down. Here, it's log base 2/3 of 8/27. So we want to know what exponent we would put on 2/3 to create the value 8/27. So 2/3 to the what power would give me 8/27? Well, I know when I take a fraction to a power, I'm going to multiply that fraction times itself as many factors as the exponent indicates. And when I multiply fractions, I multiply straight across the top and straight across the bottom. So when I look at this, I think, well, what power would I take 2, 2, and 3, 2 that I would create the fraction 8/27? Well, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. And that also works in my denominator. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. So it worked out to be to the third power for both of those. And so I have log base 2/3 of 8/27 is 3. How about this next one down? It's log base 2 of 1/2. So we want to know what exponent will we put on this base of 2 to create the number 1/2. 2 to the what power will give me 1/2? Well, I know negative exponents will reciprocal the base, and I need to have this written as a reciprocal. But that's it. I just need to have the 2 go into the denominator of the fraction. So that exponent would be -1, because 2 to the -1 is 1 over 2 to the +1, which is 1/2. So my exponent is -1, and that is my logarithm. The exponent that I put on 2 to create the value of 1/2 is -1. Now some of this is going to come into play with the other problems that we have. The next one is log base 5 of 1/25. What exponent will I put on 5 to create the value 1/25? Well, I know the relationship between 5 and 25 is that you would square it. But I want to not only square it, I also need it to go into the denominator of the fraction. The exponent that will do both of those things will be an exponent of -2. 5 to the -2 is how you get the value of 1/25. So the exponent on 5 that I need to use in order to get 1/25 is -2, so that's its logarithm. Okay, how about this one? What exponent will you put on 4/3 to create the value 9/16? Notice the base will need to be flipped over and squared to get this value. So since we need to flip the base, it'll be a negative exponent, and then square it will be the 2 part. So this is also -2. If I take 4/3 to the -2 power, that's 3/4 to the +2 power, negative exponents on a fractional base, flip the base, and then when you square the numerator and square the denominator, we get our 9/16 like we're supposed to. Okay, how about the next one? Oh, what exponent would I put on 9 to create the value 3? Well, when I'm looking at my exponents and I'm thinking about the relationship between 9 and 3, I know the square root of 9 would give me 3. And I know the fractional exponent that goes along with the square root is a 1/2 power. So I need 9 to the 1/2 power to give me the value of 3. Because remember, the 1/2 power is the same thing as the square root. So my exponent is 1/2. 9 to the 1/2 power, or the square root of 9, is equal to 3. Okay, now the last three, we're looking at some of the different properties and also to introduce some unwritten bases. So here we have log base 7 of 1. What exponent do I need to put on 7 to get the value 1? What exponent do I put on 7 to get the value 1? Well, I know any non-zero number to the 0 power is the value 1. So I need to take 7 to the 0 power to get the value 1. So the exponent I put on 7 to get 1 is 0. Now here's where we're coming into some new different ways of asking a log question. It's ln instead of log. And there's no base showing. When it's ln, that's the natural log, and the natural log's base is e. They don't write it in there, they're telling you that the base is e by spelling it ln for natural log. So when I see natural log, I want to remember that there's a base of e there. So what exponent would I put on e to create the value 1? Well, any non-zero number to the 0 power is 1. So e to the 0 is how I get 1. So the exponent I put on e to get 1 is an exponent of 0. So natural log of 1 is 0. And remember, it's not going to have the e showing there when they write it down. That's how you have to put it there when you see the spelling is ln for natural log. Okay, then this last one for the segment says find the natural log of e. So remember, the base is e if it's spelled ln. So the exponent I put on e to get e, the exponent I put on e to get e would be an exponent of 1. So the natural log of e is 1, and they won't have that base showing. So hopefully these have been some different problems that will help you work through the process. I'll do another segment where we also practice some more, as well as create a graph of a logarithmic function.